Ever wondered how random forests work in machine learning? Imagine you're in a forest, but not just any forest. This is a forest filled with decision trees, each one holding a wealth of information. Welcome to the world of random forests, a popular machine learning algorithm that thrives on diversity and collective wisdom. Think of random forests as a democratic system where each decision tree gets a vote. These trees are constructed during the training phase, each one sprouting from different subsets of the training data. When it's time to make a prediction, every tree casts its vote, and the class that receives the most votes is the selected output. This ensemble learning method combines multiple decision trees to create a more accurate and stable prediction model. It's a bit like saying two heads are better than one, or in this case, many trees make a smarter forest. Random forests are a powerful tool in the realm of machine learning, but how exactly do they work? To understand random forests, you first need to understand decision trees. Now, what is a decision tree? Imagine a tree-like structure, a bit like a flowchart. In this structure, each internal node represents a feature or attribute. This could be any piece of data that's relevant to the decision you're trying to make. For example, if we are trying to predict whether it might rain tomorrow, a feature could be today's temperature. The branches that stem from these nodes represent decision rules. These are the conditions that lead us down one path or another. In our weather example, a decision rule might be, if the temperature is below 20 degrees Celsius, follow this branch. If it's above, follow that branch. Finally, we have the leaf nodes. These are the outcomes, the end results. If we followed our decision tree all the way to the end, a leaf node might tell us, yes, it will rain tomorrow, or no, it will not. At the very top of our decision tree, we have the root node. This is the starting point, the first feature we look at. From there, we follow the branches down, making decisions at each node based on our data until we reach an outcome. So, in essence, a decision tree is a series of decisions, each one leading us closer to our final outcome. So, a random forest is a bunch of decision trees, but there's more to it than that. You might be wondering where the random in random forests comes from. Well, the secret lies in two key aspects of this clever algorithm. First, it's all about the data. Not all data is used to train each decision tree in the forest. Instead, random subsamples of the dataset are used. This method, known as bootstrap aggregation or bagging, helps to reduce the variance of the model. Secondly, randomness is introduced during the process of splitting nodes in each decision tree. When deciding where to split, the algorithm doesn't consider all features. Instead, it randomly selects a subset of features. This further increases the diversity among the trees in the forest and makes the model more resilient to noise in the data. So, the random in random forests is a strategic move. A calculated chaos, if you will, that helps to make the model robust and less prone to overfitting. Now let's explore why a forest is better than a single tree. Picture this: you're trying to solve a complex problem and you have a single decision tree at your disposal. It does a decent job, sure, but it may struggle with complex patterns and might even overfit the training data. This is where the power of the forest comes into play. Random forests, as the name suggests, consist of a multitude of decision trees. Each tree is built independently, meaning they don't rely on the results of any other tree in the forest. This independence allows for the easy parallelization of the tree building process. It's like having a team of experts, each with their unique perspective, working on your problem simultaneously. Now, these trees aren't just a crowd of decision makers. They're a team that works together to reduce overfitting. How? By averaging out the predictions. This way, the model can make more generalized and robust predictions, reducing the risk of overfitting to any particular feature of the training data. Moreover, the diversity of trees in the random forest contributes to an overall increase in the model's robustness. Even if some trees make errors in their predictions, others can correct them, leading to a more accurate overall prediction. So, that's the essence of random forests. A collection of decision trees that work together to produce more accurate predictions than any single tree could alone. So, what have we learned about random forests today? We've discovered that random forests are essentially a team, an ensemble of decision trees. They cleverly bring in an element of randomness into the model building process, enhancing robustness and preventing overfitting. Plus, they possess a unique trait of being easily parallelized, accelerating computation speed. Understanding random forests can open up a whole new world of possibilities in machine learning. So keep exploring and you'll uncover even more powerful tools in your data science toolbox.